Hello, my name is Eateroni Pizza. I've been working in OpenGL for several years now. Um, it all started when I was tired of something specific. I don't even remember what it was, but something was annoying me about Unity. So I decided to move over and try and my hand at making my own engine from scratch, which is always a terrible decision and you should never do it. But I've had a lot of fun doing it. So this video is just to show off something I did, maybe help out somebody who with an issue that I had specifically that I couldn't find a lot of information on. So let's say you've already watched Victor Gordon, you're already familiar with OpenGL and Joey DeVries' excellent website on Learn OpenGL that Gordon based his videos on. So now you're ready to like try out some new stuff that isn't in those videos. Well, I'm going to show 3D textures and how to make them work, which is really useful, I found, for animating pixel art, actually, because you can have a sprite sheet that goes in like a bunch of different directions at once, because it can be a two-dimensional sprite sheet that also has several different pages, essentially, for each of your different states or different animations. Can get really fancy with it for your animation. So first, you're gonna have your texture. I also, if you just came from Joe DeVries or Victor Gordon, you're probably gonna notice that a lot of my stuff is uh, very sparse in comparison in both comments and just boilerplate. I hate boilerplate, and I will always get rid of it. I don't really care that it's probably not as safe. I don't really know all the reasons why it's safer, so I just don't do it. And I'll deal with the problems when I get them. So here I have a texture class. It takes in a vector of strings, a directory, and a type. So for this one, we're going to be looking right here. So it takes in that type and it saves the depth of your texture as the size of this texture vector. And then it creates, I enable 3D textures and I generate a texture that's 3D. I set it to repeat in the all three dimensions, and we'll see why in a bit. And then I set it to nearest, which is like best for pixel art if you're looking at that blown up. Because if you don't, if you set it to the linear, it will look really blurry, which might be good for 3D models. Because when you zoom in on a 3D model, you want it to kind of have that smoother look. Whereas for pixel art, you actually want those jagged edges. So I use nears. Um, Flips vertically, and then I have a eye width, eye height, and eye number of channels. I use that inside this loop to check. So, and then I make a vector of unsigned characters with all data. This is not like the most efficient way to do this. Technically, I could be using a character array, like something like this. Nope, can't make it start with the number. All right, so I could do something like this and just make it width times height times number of channels times depth. However, I don't know how big my images are yet because I haven't actually loaded one. I could load one and then make the unsigned, the array, and then I could run through everything, but I decided to just make it a vector, which is, I think, technically not as efficient, but it is way, way easier. So it goes into a loop that just loops through all the textures. I have that right here. These are my textures. It's a water texture. There's 4 different layers that we're going to go through. So it concatenates the string and then loads the data with stbi load, and then if it's the first loop, it will set width, height, and number of channels using the output of STBI load. And then if it's not the first loop, it will check and make sure that that width, height, and number of channels matches what was the first one. So if any of them come up with different dimensions, it will fail, which is important because if you're doing a 3D texture or any texture, you want to make sure that like they all match up. Um, but oh, I guess just for 3D textures that makes sense. So then I just write the data to the all data structure. It just is straight up. You just go through all the numbers. This is the packing scheme for a 3D image. It's just one after the other, just as it comes out of STBI load. And then I free the data. Um, Finally, check the number of channels and get the appropriate graphics library handle for that. And then I check, hey, does the size of all data match width times height times depth times number of channels, and it's greater than 0. And if that's the case, then I bind all the data to the image. It's just as easy as that. So if you've already done a regular texture, you'll know this is pretty much identical except instead of 2D, it's 3D, and we have to do that extra step of putting all of the data into a new structure to uh, hold all those images because you might not have a 3D image already ready made, especially if you're doing pixel art. You might not be generating like a 3D image like you would for Voronoi noise or something like that. So that's the inside of it. So all we need to do is just bind it like a normal one before we draw the image. And then on the shader side, I have a pretty simple class here, um, or script here. It just takes in the position, texture coordinates, the size of the screen, position offset, and the time. And then it puts out the texture coordinates, the offsets, and the alphas. I'll show you what that all means in a bit. But then I'm just using the time to, make some sine waves. It goes through and then saves all those offsets and alphas and outputs the geo position like so. So finally we have our water fragment shader. It takes in puts out the fragment color and takes in the texture coordinates, offsets, alphas, and that 3D texture that we made. Um, so I just go through here. I offset by the offsets that we generated in the other one, the sine waves, and each of the textures, there's 4 of them. So each one will offput just like you do with the normal texture coordinates, where it goes from 0 to 1 as you go through the texture from left to right or from bottom to top. This goes from front to back from 0 to 1. So our first texture will be 0, next one will be 0.25, next one will be 0.5, and then 0.75. If you do 1, that will be the first texture again, which confused me for a little bit, but I figured it out eventually. Then I just loop through each of the things. Not loop through, but I go through each of the things. I apply the alpha from the sine wave, and then I do a transparency filter from back to front, and up with the color. And what that does is this nice little effect. Looks like that. It's just a cool little thing I worked on. I thought I might as well show it off because I hadn't seen anybody else talking about how to generate a 3D image just from pixel art. I haven't done the math to figure out how long it takes to go through every possible iteration of this image, but it's probably a lot because I used mostly prime numbers intentionally, so that they would keep offsetting and keep seeing new stuff. Um, this will hopefully go into a tactics game that I'm working on, but I just thought it was pretty cool. So I hope you appreciated this little run through. Uh, See you later.